This is a demonstration on the Boon Logic Amber machine learning and predictive maintenance solution. This demonstration of Amber is integrated with Rockwell Automation's FactoryTalk Historian and FactoryTalk View HMI application. Amber can also be integrated with AVEVA PI, Ignition, and other historians. For this demo, process simulation is set up for 4 identical assets, which are pumps with several attributes. Those attributes are pump state, speed, pressure, flow, vibration, and motor current and temperature. The attribute data is historized to the FactoryTalk Historian and organized into historian assets, one for each production pump. These assets are connected to Amber for asset model configuration, training, and monitoring. The asset process data and Amber model data are displayed with the FactoryTalk View HMI application, which is the display you are seeing here. A quick overview of this dashboard. On the left is a list of the assets. At the top is the ID of the asset and the status of the Amber asset model. The real-time compliance score is displayed via a gauge indicator, which indicates the overall health of the asset, and the compliance score is being trended here as well. At the top right, feature significance is trended for each asset attribute, which indicates how significantly an attribute is impacting the compliance score. A value of 0 indicates no impact, and a value of 1 indicates significant impact. In the middle, the novelty index is trended, which indicates how anomalous the asset behavior is. A value of 0 indicates that the behavior is normal, and a value of 1000 indicates that the behavior is significantly anomalous. At the bottom is a process flow diagram that shows the pump asset being monitored, as well as the other critical assets that are part of the process system, for which Amber asset models will also be created for the tank, a filter, and a heat exchanger. At the bottom right, the attribute data is trended, which you can see speed is 100 plus or minus 0.01%. Pressure is 70 plus or minus 2.5 psi. Vibration is 25 plus or minus 1 mil. Flow is 40 plus or minus 0.5 GPM. Current is 10 plus or minus 0.1 amps, and temperature is 55 plus or minus 0.01 Celsius. This brings us to the last feature of the demo, which is the asset scenario. For each asset, there is a unique scenario simulated that can be enabled to produce anomalous behavior for the Amber asset model. This allows demonstration of how the compliance score, novelty index, feature significance respond to various types of anomalous behavior. So for the first scenario, for the first asset, this scenario is a rapid pressure increase. Every 30 seconds of pump runtime, the pressure will increase by 1 psi. Here, the normal operating pressure as well as the current scenario pressure are displayed. Let's go ahead and enable this scenario and observe how the Amber asset model responds. From the various trends, as the severity of the pressure anomaly increased, the compliance score rapidly decreased, the novelty index rapidly increased, and the feature significance correctly identified that the pressure was the source of anomalous behavior by reporting a pressure feature significance of 1. Moving on to the scenario for pump number 2, this scenario is a gradual flow decrease. Every 30 seconds of pump runtime, flow decreases by 0.1 GPM. Here, the normal operating flow and the current scenario flow are displayed. Let's enable this scenario and observe how the Amber asset model responds. From the various trends as the severity of the flow anomaly increased, the compliance score decreased, the novelty index increased, and the feature significance correctly identified that the flow was the source of anomalous behavior by reporting a flow feature significance of 1. Moving on to the scenario for pump number 3. This scenario is an immediate pressure increase. The pressure will increase to 100 psi. Again, here the normal operating pressure and the current scenario pressure are displayed. Let's enable the scenario and again observe how the Amber asset model responds. From the various trends, when the pressure anomaly occurred, the compliance score plummeted, the novelty index shot up, and the feature significance nearly immediately correctly identified that the pressure was the source of anomalous behavior. Moving on to the scenario for pump 4, this scenario allows modification of any and all asset attributes here. Here, let's demonstrate that a relatively short duration of a low severity anomaly will only slightly impact the compliance score, and that the compliance score will recover once the asset returns to normal behavior. To do this, let's set the scenario pressure to 72 psi. Once the novelty index starts reporting anomalous behavior and the compliance score starts decreasing, we will set that scenario pressure back to the normal operating pressure, which is 70 psi. We will go ahead and set the scenario pressure back to 70. Per the novelty index trend, we can see that anomalous behavior was detected, and per the compliance score trend, we can see that the compliance score did indeed decrease. Now that the scenario pressure is back to the normal operating pressure, we see the compliance score is leveled off, and the novelty index is no longer reporting any anomalous behavior. You can also note that the feature significance is also reporting 0 now. And now the compliance score is starting to increase back to 100%, which it will do so over time as continue normal behavior is observed by the Amber model. So this demonstrates how the Amber modeling appropriately handles infrequent low severity anomalous behavior and does not report false alarms. So in summary, these various scenarios demonstrate how Amber detects early signs of failure as soon as they occur without triggering false alarms. This concludes the demonstration. We hope you enjoyed.